Hey, everybody, we are back in Unit 11. This is Lesson 1, Area of Quadrilaterals in our Tennessee Revealed Geometry. All right, so looks like we're going to be talking about base of the parallelogram, the altitude and height of a parallelogram, decomposition and height of a trapezoid. All right, let's just get into it then. All right, you guys, I'm on page 629 of your workbook, the consumable 629. All right, let's get into it. We got a parallelogram. All right, base of the parallelogram. Well, technically, they all can be considered the base. It's the parallel sides. So you got a base, 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 and base. All right, any side of the parallelogram. The altitude is the perpendicular height. So if you're a brand new teacher, you'll try, or you'll have some students that want to call this side the height, and that is not really the height. There'll be some problems later on when we talk about volume, and it's considered the slant height, not the actual true height. So height is the perpendicular distance between the base to the other base. All right, decomposition, let's see. We use the area addition postulate, decomposition of the available formula. Okay, so yeah, means we have to kind of do some manipulating and figure things out, I suppose. All right. Okay, let's see here. What we got? Imagine cutting off the right triangle. All right, so it looks like we're doing for the height. And that's the base. Area of parallelograms, product. Okay, here we go, the formula. That's what I was looking for. Area of a parallelogram is base times height. And this is the same thing for a rectangle. Area of a rectangle is base times height. Same thing for a square. Just the sides are the same. So area of a square is side times side because they're the same. Still base times height. Trapezoid's a little bit different. Sorry. And I'm actually meant to say rhombus. Rhombus, even though it's in the parallelogram family, the formula is different. It's 1/2 diagonal 1 times diagonal 2. Same thing for a kite that we've talked about previously. So that's also 1/2 diagonal 1 times diagonal 2. Okay. So I'm not sure what we're going to be talking about here. I don't know. Okay, example number 1. I'm at the bottom of page 629. And we want to find the area of this parallelogram, which is base times height. And I have the base is 23, but it looks like I do not have the actual height. I have what's the slant. I have the other base, which is 25. So 25 is not the number I can use for my height. It would give me the wrong answer for the area of this parallelogram. So they give me some extra information here, the 7, so that I can do the Pythagorean theorem to find the actual height of this parallelogram. So it looks like we're going to do the Pythagorean theorem, everybody, with 25 being the hypotenuse of this right triangle. Again, it doesn't matter which one's your a squared or your b squared, as long as you know that the hypotenuse, the c, is the 25. All right, so they've got h squared plus 7 squared equals 25 squared. So we're going to subtract 7 squared to the other side. So everybody grab your calculator, put in 25 squared, subtract 7 squared to the other side, so put minus 7 squared. You're going to get 576. And don't forget to square root that, because you're looking at h squared, and the opposite of squaring is to square root. So square root your 576, and you're going to get the height is 24. So we're going to multiply base times height, 23 times 24, and that is going to be, as you can see, 552 square feet. So there's example number 1. All right, going to the next page, we got a check. Same type problem. If you're a brand new teacher, you're going to have some students try to make 17 the height, and that is not it. That is the other base, which is in some figures called the slant height. We need to do the Pythagorean theorem to find the actual height. All right, so let's do that first. Pythagorean theorem is a squared plus b squared equals c squared. So we're going to have a squared plus 8 squared equals 17 squared. Grab your calculator and subtract 8 squared to the other side. So everybody put in 17 squared minus 8 squared. And what you should be looking at is 225. Now don't forget that is what a squared is equal to, and the opposite of squaring is 2 square root. So we want to find the square root of 225. So everybody put in square root of 225, and you should be looking at 15. So what you just found is the height of this parallelogram, the perpendicular distance from base to base, and that is going to be 15. All right, so we are looking for the area of the parallelogram, and the area of the parallelogram is base times height. We're going to multiply 21, which is your base, times your height, 15, and you should be looking at 315 squared centimeters on your calculator. Looks like the answer is A. All right, let's move on. Example number 2. Use trigonometry to find the area of the parallelogram. Okay. Actually, I am not going to use trigonometry to find the height. And here's the reason why. This is one of the special right triangles. It is a 45 degree, 45 degree, 90 degree right triangle. And what I mean to say is the legs are the same. So this is a 45, 45, 90, which means if one leg is 9 yards, the other is 9 yards. So I don't need to use trig here. I'm going to use my special right triangles. So yeah, 9 for one leg, 9 for the other leg. And that means my height is 9. Okay, so formula for a parallelogram is base 17 times height 9. And we're going to multiply those. Oh, never mind. They're asking me just for the height. So it's going to be 9 yards. Now we're going to multiply those. So we're going to multiply, okay, this is kind of weird. So that's going to be 17, because 17 times 9. So this will be 9 times 17. I don't know. This is weird. I'm not sure what it's asking for here. Okay, so this is asking for the answer right there. I got it. All right, so 9 times 17, or 17 times 9. I need to look more in my workbook. 17 times 9 on my calculator is 153, and this is square yards. So the answer is 153 square yards, everybody, for example number 2. All right, we got to check below that. All right. Got to find the area of this parallelogram. Our base is 32, and we need to find our height. All right, so again, I know it's going to want me to use trigonometry, but I see this is another type of special right triangle, the 30, 90, 60. So we teachers call this the 30, 60, 90 right triangle, 30, 60, 90, 30, 60, 90. All right, so here is the thing. What I have is the side opposite to the small angle that's 30 degrees. This makes 12 my short side. The hypotenuse, it's twice its length. So if my short side is 12, my hypotenuse is 24. But that's not the side I need. I need this side. But just knowing that this side is a hypotenuse of 24, you can use the Pythagorean theorem if you want to find the height, or if you know the other formula, then you're going to know that it's the short side, 12, times the square root of 3. All right, so you can do it either way. If you just know that the hypotenuse is twice the length, you can use the Pythagorean theorem. But if you know that the side across from the 60 is the long side, and that's the 12 square root of 3, then you just multiply your base, 32, times your height, 12 square root of 3. All right, either way, that's going to get you your answer if you use Pythagorean theorem or if you know that extra formula. So everybody grab your calculator, base 32 times the height, 12 square root of 3. And that is going to get you to the nearest tenth, 665 point. And because it's a 1, 0, it's going to be a 0.1 squared meters. So your answer is 665.1 squared meters, everybody. And that is the check and in the middle of page 630 of your workbook. All right. Moving on to trapezoids. Okay, same kind of concept as a parallelogram, talking about the height. It is the perpendicular distance from base to base. The other two are your legs of the trapezoid. They are not considered the base because they're not parallel. All right, you can have the height on the inside or you could have the height on the outside, but it is still the perpendicular base. All right, the formula for the trapezoid, hopefully it's coming up. Yep, there it is. On the next page of your workbook is 1/2 the height times, that's why these are in parentheses, base 1 plus base 2. And remember, the bases are the parallel sides. Doesn't matter which one you make 1 and 2, but typically the top is the 1 and the bottom is the 2. All right, example number 3. Here we go. All right, we got a word problem, and it looks like they need enough mulch to cover the garden. It's a raised bed, and I see we have one bag that will cover 12 square feet, and they want to know how many bags. Well, first off, we got to find the area, and the formula is right here, 1/2 the height being the 7, times base 1 plus base 2, and the bases are the parallel sides, the 1.5 and the 8. All right, so they add in 8 plus the 1.5. So I'm going to grab a calculator. I'm going to do 1/2 times 7 times 8 plus 1.5 to get what my area is. And it looks like it's going to be 33.25. All right, so this is my area, 33.25. All right, so the area of the garden is 33.25 square feet. Now, the second step is to calculate the number of bags needed. That means you're going to take the square feet and divide by the 12 square feet that they give us, because that's how much one bag covers. And if we have 33.25 square feet and one bag covers 12, we need to have, of course, more than one bag. So we got to figure out how many that is. So take your 33.25, divide by the 12. And, okay, first off, I see it's 2.77083, yada, 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 yada. But I cannot go to a store and buy 2 bags and a 0.77 of a bag. I can't do that. And I can't steal it. So I have to buy the extra bag to make up for the 0.77 part that I need. So I'm not going to buy just 2 bags. I have to buy 3 bags. And I'm just going to have some extra left over. All right, so I'm buying 3 bags, everybody, because I can't buy 2 bags and a partial. All right. Okay, done with that problem. Down at the bottom of page 631 is our check. And I'm assuming it's going to be very, very similar. All right, Miguel wants to cover the top of a desk with butcher paper. I remember when we used to cover books with paper so that it would keep it nice and neat. All right, so that brings back some memories. I'm that old, everybody. If one sheet of butcher paper covers a square meter of workspace, how many sheets will Miguel need? Okay, so first I got to find the area of this trapezoid. And I see that I have 0.9 for my height. My bases are the 1.8 and the 1.2. All right, so everybody grab your calculator, put in 1/2 times 0.9 for my height times. Now, I need to open a parenthesis so I can add my bases, 1.8 plus 1.2. Don't forget to close your parenthesis. And you should be looking at 1.35 square meters. Now, this is the area of the table, of the trapezoid table. All right. Now, the butcher paper covers 1 square meter. 1 square meter. All right, so I'm going to, of course, need more than 1 piece of butcher paper because I need 1.35 square meters. And if the butcher paper only covers a square meter, if I divide this by 1, I'm just going to get the same 1.35. So I can't use just 1 square feet of butcher paper because then I have some of the table that's not covered, the 0.35. So I need to have 2 pieces of butcher paper, and I'll just have some that's left over. And that's fine. I just got to have an extra piece to cover the 0.35. All right, so the answer is he's going to need 2 sheets for the 1 and then the extra, and then you'll have some left over. All right, so we are done with that check on page 631. Everybody turn the page. Example number 4 on the top of page 632 of your workbook. All right, example number 4. We got to find the area of this trapezoid. And I see that I do not have the actual height. I need the height of this segment. Now, what they gave me is the leg 3. That is not the height. That is like a slant height. I need the actual perpendicular distance from 2 to 4. So if you're a visual person, I need this right here. I need that height right there. Okay. So looks like they're going to have me do a split, of course. I'm going to turn this into a rectangle. This right here is what I'm talking about, which means I have a 2 and a 2. They are making this x and x, and I know it's the total of 4. Okay, so let's see where they're going with this. They're going to say x plus 2 plus the other x is 4, and this is going to get me the distance for x. Okay, I'm with them. All right, so I'm going to subtract to the other side. So x plus x is 2x, and that's going to equal 4 minus 2 is 2. All right, so x plus x is 2x equals 2. Divide by 2, it looks like x is a 1. And that kind of makes sense, you guys. If I've got a 2, plus 1 is 3, plus the other 1 is 4 total, so x is 1. And then you're going to have me do the Pythagorean theorem? Yes, they are. So it looks like my C is the hypotenuse. I have x is a 1, and I need to find the other side, which is the height of this trapezoid. All right, doesn't matter which one's your A and your B, but you do need to know that the C is the, they're going to make me do it, aren't they? Okay, there we go. What's going on here? Computer being slow is the 3 squared. All right, so that's going to be a 1 squared. Oops. All right, so 1 squared plus the height squared is equal to the hypotenuse 3 squared. I'm going to subtract 1 squared to the other side and then square root that. So 3 squared minus 1 squared. Now, if you're a brand new teacher, you may have students that will try to subtract those before they square them, and that's going to give them the wrong answer. So make sure they understand it as 3 squared minus 1 squared, not 3 minus 1 squared. All right, you do not take 3 and subtract 1 before you square. You square before you subtract. So 3 squared minus 1 squared is 8. Then you're going to do the square root of 8. And that is going to be your height, everybody. This is your height right here, square root of 8. All right, now we got to find the area. Formula for the trapezoid is 1/2 the height, which is the square root of 8 we got by doing the Pythagorean theorem, times your base 1 plus base 2. Those are the parallel sides. 2 is the top base and 4 is the bottom base. So there it is, 2 and 4. Add those together in the parentheses. All right, so everybody grab your calculator, put in 1/2 times the square root of 8 times, open parenthesis, base 1, which is 2, plus base 2, which is 4. So put in the parentheses 2 plus 4, hit enter. And let's see. Okay, they want it rounded because I see a decimal, but they want it rounded too. It does not say. All right, so I'm just going to do what they typically do and round to the nearest tenth. So you should be looking at 8.48, but the 8 is going to make the 4 round to a 5. So it's going to be about 8.5 squared centimeters, everybody. 8.5 squared centimeters. Okie dokie, here we go again. We have the check, and it's a multiple choice. All right. So what do I have? I have the base at the top, 1 1/2. Okay. I have to add all three sections together to get the base at the bottom. So I'm going to add 1/4 plus my 1 1/2 plus my other 1/4 to get the base at the bottom, which is base 2. All right, so 1/4 and 1/4 is 1/2. 1 1/2 plus 1/2 is 2. So my base at the bottom is a grand total of 2. 1/4 plus 1 1/2 plus another 1/4 is 2. All right, so my base is 2, but I still do not have, looks like, the height. So I'm going to have to do the Pythagorean theorem with the 1/4 as my either my A or my B. The height that I need for the other, either the A or the B, and it doesn't really matter which one's which because the C, the hypotenuse is the 2 1/2. All right, for my visual people, if you are sitting there going, say what? All right, I've got A squared plus, I'm going to use my 1/4 as my B. So it's going to be 1/4 squared equals, and my hypotenuse is 2 1/2, and I'm going to square that. So 2 1/2 squared. All right. It's not letting me put in the fraction, so I just changed the 2 1/2 to 2.5 just to be a little bit easier. All right. Here I'm going to subtract. The opposite of adding 1/4 squared is to subtract to the other side. So I'm going to subtract 1/4 squared from the 2 1/2 squared. All right, that's going to leave me A squared. All right, grab my calculator. I'm going to put in 2 1/2 squared minus 1/4 squared and hit enter. And that's going to give me about 6.1875. Now, remember, this is not my answer. This is not my height because that is what A squared is equal to. The opposite of squaring is to square root. So I'm going to square root this 6.1875 to find out what my actual height is. All right, everybody, grab your calculator, square root the 6.1875, and that's going to give me my height, which is about 2.487, yada, 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 yada. Now, remember, this is my height. I just found. I did all of that just to find H for my formula. All right, so now I've got everything that I need for my formula for the area of a trapezoid. So here goes. I'm going to have the formula 1/2 height times base 1 plus base 2. So grab your calculator, put in 1/2 times the height, which we found to be that this right here, 2.48 thing. So 2.487, yada, 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 times, open parentheses, base 1 was 1 1/2, add the other base, remember that was a 2, because we added all of these three sections together, close your parenthesis and hit enter. So you're looking at about 4.35. Looks like the answer is A, 4.35. Yep, there you go. The answer is A, everybody. And that's our check on page 632 of your workbook. All right, we're going to start getting into the rhombus and kite. Now, I gave you the formula at the beginning of this lesson, but here it is again. The formula for the area of a rhombus and a kite is 1/2 diagonal 1 times diagonal 2. So you need to have the diagonals for both the rhombus and the kite in order to find the area of them. And if they do not give them to you, you might have to do a Pythagorean theorem because these are all right triangles. Right triangle, right triangle, right triangle, right triangle. Same thing for the kite. All four are right triangles. So they don't give you what you need. You may have to do the Pythagorean theorem. I don't know yet. Let's see. Example number 5 on page 633, where we find the area of this rhombus. All right, find the length of each diagonal. Okay, so looks like that 6 is just half of the diagonal. And that means I'm going to have to add 6 plus 6 to get a grand total of 12. The other one, half of the diagonal is 7, which means the other half is 7. So I'm going to have to add those together and get my fingers to work correctly to get a total of 14. All right, here goes step number 2. 1/2, 12 times 14. All right, grab your calculator. Put in 1/2 times 12 times 14, or you can realize that 1/2 of 12 is 6. 6 times 14 is 84 squared millimeters. All right, there's your answer, 84 squared millimeters. All right, check. Here we come. Okay, it's the same thing, but they actually trying to trick us. The other diagonal is 18. They put it down here, I guess because they just don't want to put it straight through the 10, maybe. Who knows? But my diagonal is 10, and my second diagonal is 18. So I actually have everything that I need. Grab your calculator. The formula is 1/2 times diagonal 1, which is 10, times diagonal 2, which is 18. Or you can flip-flop those if you want to. It doesn't really matter. Multiplication is the same regardless of which way you do it. So 1/2 times 10 times 18, or 1/2 times 18 times 10, whatever, is 90. The answer is B. All right, example number 6. All right, at the bottom of page 633, we have to find the area of a kite, which is the same formula as the area of the trapezoid. All right, looks like they gave us what we needed. We need the diagonal 1, which is 9. We need the other diagonal, which is 16. There it is right there. So it's going to be 1/2, 16 times 9. All right, grab your calculator. Put in 1/2 times 16 times 9, or you can realize that 1/2 times 16 is 8. And then 8 times 9, that's going to be 72 squared inches. All right, there is our answer to example number 6. Hope everybody's doing okay so far. If you're not, ask me. Ask your teacher. All right, the area of this kite. Okay, looks like they give us what we need. We have diagonal 21 and we have diagonal 17. So everybody grab your calculator, put it in 1/2 times 21 times 17. Gonna get a decimal. If you're a brand new teacher, you're gonna have students that's gonna think this answer is wrong. 178.5 square meters. I don't know. It's a daily struggle, brand new teacher. You're going to have students that think this is wrong. What did I do wrong? Well, what'd you get? 178.5? You got it right. Well, no, I got a decimal. It's still right. That's going to be a struggle for all the years that you teach. All right. Okay, moving to the next page. Example number 7, going to find the missing measures. Okay, so this time they do not give me what I need. I have the length of one diagonal, 58.88 centimeters, but I do not have the other diagonal. They say it's X. Let's see what we do have. All right, one diagonal of a kite, 55.88. If the area, okay, so they give me the area, all right, which means I'm going to plug that 92 in for the A in the formula for the area of a kite, and I'm going to solve for the other diagonal. Okay, so everybody, we're going to take 92. We are, all right, what are we doing here? Convert units. Oh, no way, they try to trick me. Oh, they're so mean. Yes, they did. Look at that. They give me 92 square inches, and then they put the diagonal in centimeters. Tricky, tricky, tricky. All right, so we've got to recall that 1 inch is 2.54 centimeters. I love trick problems. All right, so take your 55.88, divide by 2.54 first, because we're going to convert centimeters to inches. 55.88 divided by 2.54. So it looks like it's going to be 22 22 inches. Tricky, tricky, tricky. I love it. All right, now we're going to use our formula. Step number 2. So I'm going to replace the A with the 92 because that is your area. I'm going to replace one of the diagonals with 22 inches, not 58.88 centimeters, because I had to do a little conversion there. Now I'm looking for X, which is my other diagonal, in inches. All right, well, 1/2 of 22 is 11. And the opposite of multiplying by 11 is to divide by 11. So everybody take 92, divide by 11. And again, you're going to get a decimal. 8.36, yada, yada, yada. Looks like they round that to 8.4. So the diagonal is approximately 8.4 inches. All right. Oh, we got to check. Got to check. Got to check. All right, looks like this is our last thing. All right, we got a rhombus. All right, it says A to E is 7.3. Don't forget, I've got to double that to find AC, which is one of the things I've got to find. Interesting. All right, so A to E is 7.3, and because it's a rhombus, the diagonal was bisected. That means the other part of that, CE, is 7.3. So 7.3 plus 7.3 is the length of AC, which is 14.6. All right, so there's the length of my diagonal. All right, then they give me the area of the rhombus is 96, and I've got to find X, and looks like I got to find, or double it to find BD. Okay, here we go. For my visual people, the area is 96, was it not? Yeah, 96. So 96 equals 1/2 times, all right, diagonal 1, which was our 14.6, times diagonal 2. Well, if B to E is X, that means D to E is X. So my entire diagonal for right now, BD is 2X. Okay. So let's see. I'm going to go ahead and take half of the 14.6. All right, so I got 7.3 times 2X. All right, 96. All right, I'm going to multiply 7.3 times 2. I got 14.6 X. All right, and the opposite of multiplying by 14.6 is to divide by 14.6. So I'm going to take 96, divide by 14.6. All right, looks like X is about 6.6. I guess I'll round to the 10th because that's what they asked me to do right there. So X is 6.6. 6.6. Now remember, that's the distance from B to E. And because this is a rhombus, the diagonal has been bisected. D to E, also 6.6. But they want BD. So take your 6.6 from the top, add it to the 6.6 at the bottom. All right, so double that, 6.6, and you're going to be looking at 13.2. There's your length from B to D, everybody. Woo-woo. All right, we are done. Your practice is up next. No, I'm not going to do that for you. You got any questions, ask me or ask your teacher. Good luck, everybody. Have a good one.